Hello, I'm Miss Allison.
And I'm Miss Erin.
And welcome to Simply Science. Today we are discussing density. So first, what is density?
So density is the amount of mass per volume that an object has. So mass is the amount of matter that is in an object. So it's easiest to think about it as how heavy it is, although that's not 100% correct because of gravity.
But if you think about matter, if the matter is tightly packed together, doesn't take up very much space, like a rock, it's got more density than, say,
a piece of paper.
Yeah, paper's perfect example. Takes up a lot of space, but the particles
Actually, though, Miss Allison, let's roll up that piece of paper.
That's true. Takes up less space. However, the particles are still pretty spread out, not nearly as dense as our rock, so it's not going to feel nearly as heavy.
So volume-wise, they're about equal. They take up around the same amount of space. But density-wise, our rock is going to be a lot more dense. We're going to put some objects into water to help you see how dense they may be. So our rock, obviously going to sink down to the bottom.
So if it's more dense, it's going to sink. However,
our piece of paper, it's going to float along the top like a boat.
Pretty cool. Let's do some other experiments with some objects that are going to sink or float. So while we're testing these out, we'll show you what we're doing, and you make a guess on whether you think they're going to sink or float. If you enjoy pelicans here in Lincolnton, here is the Pelican Coin. Let's see if it'll sink or float. Straight to the bottom.
How about a marble? Oh, it sank. Let's see. A rubber band. What do you think this is going to do, Miss Allison?
Maybe sink? Let's see.
No, it floats.
It floated. All right, now we've got a block here.
It's a foam block.
So let's see if the foam block is going to sink or float.
It floats. So let's take some of these out so we can add some new things in.
All right, we have here a jingle bell. Let's see if it sinks or floats.
Oh, that sank pretty fast. So let's check a golf ball. I'm actually a little surprised on that one. I thought it might have floated.
Me too. Golf balls kind of have funny insides if you ever cut one open.
Just be really careful if you do.
Yeah, don't do it without your parents' permission.
Here's and safety glasses.
Straight to the bottom.
A toothpick. It actually floats.
Now, Miss Erin and I want to show you a really neat experiment with a couple of eggs we have here.
So we have one plain plastic Easter egg. I'll pass that to you. We have one Easter egg with a rock in it. So what do you think is going to happen with each of these eggs?
Think this one's gonna sink?
Think this one might float?
Well, let's find out. So remember, mine was the Easter egg that was empty, but is it really empty or is there matter in here? Think about that.
So this one has a rock.
Now, why are they both floating? Let's explore that just a little bit. Remember when I asked you if this egg was empty? It's actually not. It is full of a state of matter called gas. That's the air we breathe.
So this egg had a rock in it, but it also still has air. So let's see if adding an extra rock and maybe some marbles will make it sink. They've taken up a lot of the space of the air. It still floats a little, not nearly as much as it did. So I bet if we continued adding additional mass to it,
we would maybe get it to
eventually sink.
Now, let's experiment with some common fruits you may know. We have a lime, a lemon, orange.
So let's see what happens with them. So we've got our orange. You might think an orange is pretty heavy, but there's actually a really good reason that it floats. Its peel has some open spaces that have air pockets. I'm going to pass this to Miss Allison to make a change to it that's going to make it do something different. So while she's peeling it, I'm going to toss in our lemon. Our lemon is also going to float for the same reason. It's got a thick rind that has some air spaces in it. That orange smells good. It's making me hungry.
I'm still working on this one.
So now a lime doesn't have as thick of a rind. So let's see what happens to it. So it's not as buoyant or doesn't float as much as our lemon did. That's because it lacks a lot of those air spaces.
Now let's see what happens to our orange now that I've peeled the rind mostly off, and those air pockets are now mostly gone.
She's almost got it.
It's a big orange, Miss Erin.
Sorry, it was what they had at the grocery store. I think we're ready.
All right, we're gonna toss it in and see.
Again, it floats a little bit. Oh, actually, it just decided it's going to sink and settle to the bottom. If you look really close, you can actually see some air bubbles escaping from it.
So that's what these peels hold. Lots of air, and they protect the fruit. Now, we're going to move on to another experiment with density.
We're going to slide this to the side so you can see better.
We have some stuff you might have around your home. Everyday things. We're going to test out their densities. Now, reviewing matter, that all of these are in liquid state. So they are all liquids. We're going to test them out and see them. We're not going to tell you what liquid is what just yet, but we're going to test out the liquids and see if they have different densities.
So we're going to pour in our first one, which is green.
Erin has a mystery green liquid there. So pour in. Let me do it. I'm gonna do that one first.
Yes. So y'all can tell what this one is.
That one's not a mystery. Now, so take a look there. The brown and the orange, the brown and the green did not mix. You would think they would have, but they have not. So
it's because they have different densities.
That's right. So which one do you think is heavier? The chocolate syrup or that mystery green liquid we had at the bottom?
So which do you want to put in next?
Let's try.
We have our mystery yellow liquid or our dish detergent.
Let's try our dish detergent just to see.
So we're not going to put in a whole lot of dish detergent.
And you can see it's blue.
We maybe need a little bit more because I can barely tell it's in there.
Now
there we go.
You can really see it. If you take a look at that now, you can see definitely 3 distinct colors. We've got the green, the brown, the blue, but they're still not mixing.
So let's add in our yellow liquid.
All right. Now, usually when you mix blue and yellow, you get
green,
but our blue and yellow looks pretty separated here.
Okay, so our last one is our red liquid. Should maybe add in a little bit more of that. That way we can see better. Now, what just happened, Miss Allison? I poured our red liquid on top of our yellow liquid.
So if the red liquid went under our yellow liquid, that must mean it's more
dense.
So it has more mass.
So let's take a look And we'll identify now what our mystery liquids were. So at the bottom, our green layer.
That is corn syrup. Very dense. If you try to make it flow, it doesn't flow very easily.
So our next liquid,
Still liquid.
as you saw, was chocolate syrup. So less dense than corn syrup, but still pretty dense.
Now
And
our third liquid you saw
Our
was
blue
our
layer.
dish soap. Not quite as dense as the chocolate syrup
So
or the corn syrup.
the fourth layer is actually just colored water.
And our last layer is canola oil, which is much less dense compared to all of these other liquids.
So this is something that you can try at home with different liquids you have around the house. Just make sure that you get parent permission first. And actually, we suggest using these same liquids. Try it out on your own. Try putting them in a different order. See what happens.
Another interesting add-on to this experiment, you can add a marble, an olive, and a marshmallow and see where they fall into the column as well.
It's like, where is our marble? Ha ha! Forgot I put it in the egg.
And it's important, if you do this experiment, you have to do it in that order. You have to add the marble first, then the olive, then the marshmallow. So, just make a prediction. Where do you think the marble's going to fall in our density column? Might take it just a little bit.
I think it's stuck in the chocolate syrup.
It might be. Looks like it's trying to come through there. If we let it sit, it might. That marble.
Oh, yep, there
may-
it comes.
So you experiment with an olive and a marshmallow and see where those fall in our density column.
So thank you for tuning in with the Lincoln County Public Library. We'll see you again next time.